Good evening, and this is X-rays. And I have allotted 2 lectures for X-rays. We should be able to finish X-rays and the required number of questions in these 2 classes that you have. Now remember this photoelectric effect, matter waves, and X-rays. You can have anywhere between minimum 1 to maximum 2, say 3 questions. Not 3. 3 would be on the higher side probably, but yeah, at least 1 question you will have. At least 1. Maximum 2 or 3 matter waves, photoelectric effect, and your X-rays, and everything that you need to know. I will tell you. I'll also show you the questions from the previous years, the latest previous year that has come. Remember, this topic is almost exactly similar to what we have already done, and that is why I do photoelectric effect, then X-rays. Then we'll move on to modern physics, and we'll be covering modern physics in about 10 to 12 days. And again, at least 3 questions can come from that topic. So whatever we have done from photoelectric effect to modern physics, when we are done with it, we will be covering at least 5 to 6 questions that are sure shot in your paper. Sure shot. So if it is 5, then it is 20 marks. If it is 6, it is 24 marks. Done and dusted in the bag. It is there in your bag. So please be attentive. And the questions that I are going to face in these topics are very, very simple. Simple question based on simple concept. If you take a deep breath, you should be able to do them. And these are the first questions that you should try in your paper. And then I will try and cover your rest of the topics in the regular class. Whatever topics are remaining for the 11th, I'll cover them in the Sunday wala class if you don't have any doubt. So in the Sunday wala class, I'll cover that topics. In this class, I will cover this. And if everything goes well, according to my plan, we would be able to finish your entire course by mid of January or end of January. Latest, if everything goes well. Okay, entire course, when I say entire course of 11th as well as entire course of 12th, you should be able to get to that stage. Having said that, let us move on to X-rays and why they are called X-rays. Everyone knows this, right? Why are they called X-rays? It was discovered by a scientist known as Ronton. Have you heard his name? This was discovered by a scientist named Rohinton, and he was conducting an experiment for something, but he found, oh, his spelling is wrong, GEN. He was conducting experiment for something else, but then he found out this. He did not know what to call them. So in maths, they call unknown quantity as X. So he started calling them X-rays or Rohinton rays or X-rays. This is how these were discovered. Now, as soon as we hear about X-rays, and again, this entire chapter is based on one diagram and 2 or 3 graphs. The entire chapter is based on one diagram and 2 or 3 graphs. So if you can understand this, we are done. Now, when we understood a photoelectric effect, we understood it by a diagram, right? The experimental setup of photoelectric effect. We had a cathode, we had an anode, light was falling, ding, 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 and things were happening. Similar things happen here, and this is the best diagram that I found. So this is the diagram that you are going to draw, and we are going to understand this diagram in detail because this is the entire diagram. Oops, where is the diagram? This is the diagram that based on this diagram, you are going to get almost 80 to 90% of the questions from X-rays. The rest is just 10% on the graphs. What is this known as this setup? Anyone? Any idea? This is the setup to. This is the setup to study these X-rays, and this is known as the Coolidge tube. This is known as the Coolidge tube. Which tube? Coolidge tube. Coolidge tube setup to understand X-rays. Oops. It looks quite frightening, but it is not that frightening. If you try to understand them, don't draw it first. Try and understand what all things are happening here. Okay. Now, First of all, you have to understand how X-rays are produced. Now, how X-rays are produced. Now, let's go back to how photoelectric effect was happening. This was a metallic plate. Light was falling, ding, 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 ding. And work function, ding, 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 ding. And electrons were emitted. That is how your photoelectric effect or photoelectrons were emitted. We call it photoelectric effect because it was because of energy given by these falling photons. When I was discussing photoelectric effect, I told you that is not the only way which electrons can be emitted, right? That is not the only way in which these electrons can be emitted. Electrons can be emitted by different ways. Basically, these electrons are revolving and they are bound to the nucleus. If you can somehow give them sufficient energy that they leave nucleus, you have a current. Yes or no? One of those methods was heating up the element. Yes or no?
Yes, sir.
Or no? One of those things was heat up the metal. Now here, that is what it is used. Do you see this filament F? Do you see this filament F? This is nothing but a heater. Now what happens is you pass current through it, and this current is important. You pass current through the filament. When you pass current through the filament, this filament gets heated up. It's made up of a metal. It gets heated up. So what happens? It emits what? Electrons. It emits electrons. Dum, 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 dum. Now, these electrons, they may not have sufficient energy. To give them sufficient energy, we are connected this to a voltage. So do you see this voltage source? Now negative, the filament is cathode and the other side is anode. So when the filament is cathode and electrons are getting emitted, it is negatively at negative potential. So what is it is going to do? It is going to increase the speed of these electrons. Yes or no? There, photoelectrons were emitted by the anode. Here, electrons are emitted by the cathode. And then we give it a negative potential. So what happens is high speed electrons gain speed. High speed electrons are emitted and they hit this T target. It has been found that when this high speed electrons hit a target, which is a metal, heavy metal, large atomic mass, large atomic weight, when these high speed electrons hit a metal of high atomic weight, some electromagnetic radiations are emitted. And this is these electromagnetic radiations that you see, they are emitted. These electromagnetic radiations are known as X-rays. So if I look at it, it is actually sort of the reverse of the photoelectric effect. In photoelectric effect, light was hitting and electrons were going like this. Here electrons are coming like this and radiations are getting out. Do we understand this? Sort of when I look at it, I look at it in the reverse order. It is all actually sort of the reverse of photoelectric effect. In photoelectric effect, radiation was falling on a metal. Here, radiations are emitted by the metal. These radiations are known as X-rays. Do we understand this? These radiations are known as X-rays. So, what do we need to produce X-rays? What do we need to produce X-rays? Number one, what do we need?
Current.
We need a source of electrons. We need a source of electrons. What is the source of electrons here? What is the source of electrons here?
Filament.
Filament is the source of electrons. And how are electrons emitted by the filament? by ionic emission. Okay, we'll write them, don't worry. All these points we'll write them. So we need a source of electron. What is the second thing that we need? We need an arrangement to accelerate the electrons. How are the electrons accelerated here? The source of these electrons is this filament. How are we accelerating these electrons? This. We use this battery to accelerate these electrons. We use this potential difference to accelerate the electrons. Do we understand this? And what is the third thing that we need to produce X-rays? It is known as the target metal. Target. It is the target target metal of high what? High what? High atomic weight. These are the three things that we need to produce X-rays. Since I am run out with the sheet, so you will have to draw this diagram. Can you draw this diagram? Yes or no?
Yes, sir.
You may not have to draw the exact shape. You can draw it in a rectangular block. Doesn't matter. It must be able to make you understand what is being drawn. Nothing else. And then we will see what metals it is made up of. Just draw the diagrams and just write these three things. Are you able to draw the diagram, or shall I give you a more simpler one? You just have to understand what are the basic elements. You must have a filament. You must have a target. Filament must be negative and target must be positive. We understand this. And as soon as the electrons hit the target, well, we have X-rays being produced. Once you are done, please let me know so that I can give you that important points, everyone.
Completed, sir.
Boys, shall we go ahead? Or you want more time?
1 minute, sir.
1 minute, I can wait. 1 minute is not a problem.
Completed, sir.
Okay. Now, whatever we are going to write, I am going to give you in point-wise fashion. Please note down these points. The first point is when high speed electrons hit a metal of high atomic weight, X-rays are produced. This is the first point you must remember. How are X-rays produced? This is as simple as it gets. So that means in this one line, we understand that there are three things that are required to produce an X-ray. The first is a source of electron. The number two is to make it high speed. Number three is a target. Do we understand this? You written all those three things? Yes or no? Huh?
Yes, sir.
Written, sir.
Okay. Now, one by one, we will write the elements. The first element is filament. The first element is filament. What is the use of this filament? Yes.
Produces electrons.
It is the producer of, or it is the source, not producer. Producer would be a wrong word. Source of electrons. Point wise, point to point. Source of electrons. How is the electrons produced? How does it give electron? By heating. We call it ionic, right? We call it therm ionic emission. So it emits electrons by therm ionic emission. This filament is also getting current in it. Current I in the filament controls what? Controls what? Do you see this current in the filament? This gentleman, this filament also has a current I. Did you draw this current? Huh?
Sure.
What does this current control? You understand it here? What does the current control? If I increase the current, then what will happen? Huh? This is common sense. This is not physics. If I increase the current, what will happen? Arey, say.
Heat increases, sir.
So what will happen if it increases?
More
Emission of electron increases.
thermoionic emission is more.
Yes. The current in the filament controls the number of electrons. The number of electrons. Controls the number of electrons that are produced. When current is increased, it implies the number of electrons will be increased. Number I should write. Number of electrons will increase. Now, apply common sense. This is not physics. If more electrons are falling on the target, then what will happen?
More X-rays.
Yes, it is common sense. More X-rays. Number of X-rays increase. More X-rays are formed. Now, again, go back to the chapter on photoelectric wave. If you have more photons or more X-rays being formed, what it actually means in terms of energy or power or intensity?
Intensity.
More is the intensity of X-rays. More intensity of any radiation means more radiation is coming out. That means this controls the intensity of X-rays. This is the most important term that you have to understand. This controls the intensity of X-rays will increase. More X-rays will be formed. If you have 5 electrons, maybe 10 X-rays are coming out. If you give 10 electrons, maybe 20 X-rays will come out. More X-rays, more X-rays, more X-rays. Do you understand this, or this has gone above and saying bye-bye? I'm going, don't worry about me. Huh?
Yes, sir.
Okay. This is the source of electron. Current in the filament controls the intensity of X-rays. No, just because you understand Coolidge tube, do not go and start producing X-rays. These are very dangerous. So I know how to produce X-rays, so I'll heat up a filament and make it fall on a current, and X-rays will be produced. That is why is this gentleman surrounded by lead chamber? Do you see this lead chamber? No one asked me this. Lead chamber? For protection. X-rays are dangerous. You must have gone for an X-ray when your haddi got broken. And they keep it in that, and they put all sorts of scary things, that the two bones and that skeleton, so that you stay away. Radioactive lead absorbs those radiations. That is why lead chamber. So now the other two minor points, they might not ask this minus point. What is this? What is this? What is this? What is this made up of? It is actually a tungsten filament. Tungsten filament is used for this one, and it is coated with. This is just for your academic thing. If you want to, if a question on X-rays comes in your 11th and 12th board, it's coated with barium, with oxides of barium or strontium. Barium and strontium. Why? It is coated with barium and strontium to have emission of electrons even at low temperatures. Even if the temperature of the filament is low, even then they would be able to emit the electrons, and that is why it is coated with oxides of barium and strontium. That is the first element. Filament. What is the next element that we must talk about? Huh?
Targets.
No, not the target. Let us talk about the the what accelerates the electrons. Potential difference.
Voltage.
The second thing is voltage source. This voltage source creates a potential difference between filament F and target T. Do you understand? F and T? Filament and target. This filament is kept at a negative voltage. It becomes the cathode. And this gentleman, the target, is made the anode. The potential difference is high. The potential difference V is of order of 10 raised to the power 8 to 10 raised to the power 10 kilowatt to 80 kilowatt. This is of no use. This is just for your academic purpose. What is the purpose of this voltage source? The purpose of this voltage source is to accelerate the electrons, to give them more energy. Now, the next thing, if the potential difference between filament and target is increased, then what happened? Then what will happen? If I increase the potential difference between the filament and the target, then what will happen? Huh? Nothing, sir. I do it. What will happen? Nothing will happen. What will happen?
Electrons accelerated.
The energy of the electrons increase. So what will that happen? What will that lead to? This implies the energy of electrons, or the kinetic energy of electrons. Say same word, kinetic energy. Kinetic energy of electrons is increased. So what? So what? What will that happen? What effect that has?
Electrons move fast.
So
More X-rays.
more X-rays. If electron move fast, then more X-rays. No, that does not suit the logic. The previous logic was correct. More electrons hitting, more X-rays. Yes, I understand. But more energy electrons hitting, more X-rays. No. That does not fit the logic. Then what will happen? Huh?
Emission of X-rays is fast.
No. Emission of X-ray is not fast. Energy, kinetic energy. When the potential difference PD increases, that implies the kinetic energy of electrons increase. More energetic electrons are hitting the target. So what will happen with the target? Huh? More energetic X-rays will come out. Energy of X-rays increase. Energy of X-rays increase. You will have X-rays with more energy coming out. More deadly X-rays. More energy means it can do more damage. More penetrating power. We will come to that. X-rays, don't worry. So potential difference, changing the potential difference between the cathode and the anode leads to more energetic X-rays coming out because more energetic electrons are hitting. If you increase the current, more electrons are hitting. So more X-rays come out. More energy electrons hitting, more energy X-rays comes out. Do we understand this or this is gone about at saying bye-bye? Bye-bye, both ho gaya. Enough. Our minds are so small and how much we have built an entire Coolidge tube. And now we are understanding how X-rays are coming out of that Coolidge tube. Do we understand this?
Yes, sir.
That is the second thing. What is the third thing? Everyone noted this down?
Yes, sir.
The third thing is the target. The target is what emits X-rays. So it produces X-rays. What should be the quality of the target? Right? Why? What quality, sir? Put anything. What do you mean by quality? Huh? What do you
High
mean?
atomic weight.
Characteristic of target. Quality of target. The target. So let me write the characteristics. Characteristics. Number one, it should be of high atomic weight. We'll understand this. Give me some time. Why high atomic weight? We'll understand this. Don't worry. Any other characteristic it might have? It should have.
Be a metal.
It's always a metal. ठीक है. Anything else?
High melting point.
Which notes are you referring to? High melting point is correct. Why high melting point? When X-rays are produced, these high energetic electrons are hitting it. The target gets very hot. Temperature increases. If it is made up of a metal which has low melting point, it will melt and instead of X-rays, this molten metal will come out of the window. We don't want molten metal to come out of the window. We want only X-rays to come out. So therefore, it must be having high melting point so that it does not melt. Any other thing might have? We just read it in the class on Sunday. High thermal capacity or specific heat, so that whatever heat is getting generated, it can let it go quickly. If it has low specific heat, it will take more time to take heat out of it. Should have high so that it can give heat out quickly. Do we understand this, or it has gone above our head saying bye-bye?
Yes, sir.
Okay. Now, the normal metals that are used here are tantalum. This is just for your academic purpose. No one is going to ask you platinum, etc. You don't need to know this. One thing that you must see here is we have got one more thing. So you can also use tungsten here. So that is just an example. There was this. Did you see this? Dung 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 dung. Why this?
For cooling, sir.
For cooling. This water is for cooling it, because it will get very hot. We want high thermal capacity, but we may also have some means of removing the heat. So this water removes that heat so that it cools down. Do we understand this? Yes or no?
Sir. Yes, sir.
Coolidge tube. That's all. That's all production of X-rays that we need to understand. Have we noted it down?
Yes,
Yes
sir.
or no? No, yes.
Yes, sir.
Then there are two types of X-rays that we would encounter based on their. Now, whenever we talk about X-rays, let me take it this way. Whenever we talk about X-rays, we talk about two things of the X-rays. Two characteristics of X-rays. The first characteristic of X-ray is the intensity of X-rays. Intensity means the quantity of X-rays. Intensity means the number of X-rays. How can you increase the number of X-rays?
By increasing the number of electrons.
So that is controlled by the filament current. So this intensity of X-rays I is directly proportional to the current I. Do you understand this? I, capital I stands for intensity, small I stands for the current. Okay. The intensity of these X-rays is directly proportional to the filament current. More filament current, more intensity, more X-rays, more number of X-rays, take it. The second thing that we talk about this X-rays is known as their energy, or we have another term quality, or we have another term penetrating power. All mean the same thing. Now, the X-ray which has more energy will have more penetrating power, and that is known as the quality of the X-rays. So this actually refers to the energy of X-rays. And who controls this energy?
Voltage source.
Potential difference V, or I should say it in the other way. The energy of X-rays is controlled by the voltage difference V. The voltage source controls it. Now, based on this, I've written the spelling of quality wrong. I've written quality. It's not quality, it's quality. Instead of L becoming T, T has become L. Anyways. So based on this quality of X-rays, X-rays can be divided into two categories. The first category is known as hard X-rays, and the other one is known as soft X-rays. So based on the qualities of this or penetrating power of these X-rays, X-rays can be subdivided into two categories: hard X-rays and soft. And as the name suggests, we could understand what is an hard X-ray and what is a soft X-ray. Tell me, what is a hard X-ray, what is a soft X-ray? Nah? A hard X-ray is an X-ray which has
Potential difference is less for
a hard X-ray is an X-ray which has got more penetrating power, hard, more frequency, more energy, more penetrating power, more frequency, less wavelength. Frequency and wavelength are inversely proportional. Soft X-rays, they are soft, less penetrating power, they don't go so far, less energy, less frequency, more wavelength. Do we understand this?
Yes, sir.
Hard and soft X-rays. Classification of X-rays on the basis of their what? Quality, penetrating power. Do we understand this, or this has gone above our saying bye bye? I'm going, don't worry about me. Huh?
Yes, sir.
Gone above our heads? You said yes, sir.
Understanding, sir.
I thought it has gone above our heads. That's why you said yes, sir. Okay. Now, what are we going to do? Since only 5 minutes are left, I cannot move any further, but I can show you probably. 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 Where is that? Let me just see if I could get a question from okay, it would be in that section. Okay, hard and soft X-rays are done, and I will find a question which has come on this in your previous year. So that is what I'm looking at. I have this previous year paper. Not there. No. Must be. Okay, this is X-rays. Okay, again, we have not covered this. See, I got this. So remember, you will have question based on this Coolidge tube. The probability of it is coming is high. This is a question from one of the previous years. Fatafat, read the question, get me the answer and stay happy. Tell me the answer. Read the question on your own. Till then, I will find out the next question. Yes. The potential difference between applied to an X-ray tube is increased. As a result, in emitted radiation, what increases? Okay, you can't even solve this. Now you can solve this. Now potential difference increased.
intensity remains unchanged.
Intensity remains unchanged. That is correct. Even though I have not told you about these two, what is minimum wavelength? This minimum wavelength is actually going to come in the next class. And the problem is that all the question that I see here, it has some element of that minimum wavelength. So I can't give you any other question from here. Anyways, I'm already done. The next class, we will be dealing with the types of X-rays based on how these X-rays are formed, or what is the phenomena behind these X-rays. So we will cover those things in the next class, and in all probability we would be finishing your X-rays by this next class. Now remember, from this topic and the previous one, you should have at least one question at least. Again, this is k lambda. You can't do k lambda right now. Okay, so I did not find any appropriate question that we can do at this point in time apart from this one, even though it had two parts which was not covered up till now. So we will continue with X-rays in the next class. only two things you have to remember. What are the elements of this Coolidge tube, and what happens when you change intensity, and what happens when you change the potential difference. These are the only two things you have to remember. I hope you have understood this, yes or no?
Yes, sir.
And you can think of X-rays as the reverse of photoelectric effect. Okay, so I'll see you in the next class. Take care. God bless you all. Bye bye.
Sir.